Traditionally, when you make a part out of plastic without a 3D printer, it's either going to be one big solid lump or just a hollow shell. But as we know, your printed parts are composed of a solid outer shell and a supporting infill structure. And in Slicer, we are granted the ability to change how these features are going to be generated on our part. So in this video, we're going to focus on changing the outer shell, and in the next video, we'll focus on playing around with the infill. How thick of a shell you choose to print with is going to affect part strength and stiffness, print times, and your material usage. A thicker shell is going to use more plastic, and the printer is going to take more time to put down these extra layers. And obviously, a thinner shell will achieve the opposite of this. The shell is also going to affect the overall strength and stiffness, with the biggest effects in increasing its resistance against bending and torsion forces. So let's jump into Slicer, and to change these settings we're going to need to venture into the Print Settings tab, where we will find it under the Layers and Perimeters menu. All the settings that we're going to be changing are within these two boxes. So vertical shells are the ones that are going to have print lines and run along the z-axis. And these are going to be the easiest to work with, as their thickness is always relative to nozzle diameter. By default, most printers are going to have a 0.4mm nozzle. So if we have 2 layers in our shell, the shell thickness is going to be roughly double the nozzle diameter. And if we have 4, it's going to be roughly 4 times the nozzle diameter. The horizontal shells are a bit different because the total shell thickness is going to be dependent on layer height. Right now we've got it on the 0.3mm preset, and under this preset, Prusa is going to give us 4 top layers making 1.2mm and 3 bottom layers making 0.9mm. And so if we go to a lower layer height preset, we can see that the slicer is going to automatically bump up the amount of layers to compensate for this and give us about the same thickness shell. Now it is normal for the shell to be thicker on top than it is on the bottom, and we will explain this in the wiki below. Now by default, your vertical shell thickness is going to be about 0.8 mils, and your horizontal shells are going to be between 0.6 and 1mm. So let's look at some examples when we should change these values. Let's say we were printing this large decorative Christmas tree. Most likely I would be printing this on 0.3mm, and on this setting I'd whack it maybe down from 4 and 3 layers to 3 and 2 layers. I might keep it on 2, but in this case I'll drop it down to 1 vertical shell to try and save on some more time and plastic. And as you can see, we've saved a little bit of time and materials, but for these small gains in print times and costs, we have lost a lot of strength on this part, but it's completely fine. It's just a decorative piece that's going to sit somewhere. Of all the times I printed with a thinner shell, I think the best example of it was when I was printing the wing of a remote control plane. So this is a section of it we're going to print, and we really need to keep that weight down. So I'm definitely going to drop it down to 1 vertical layer and maybe a couple of horizontal layers. Just be wary that when you drop the horizontal layer down to 1, it's going to be incredibly easy to just puncture through that thin wall. Alright, so when you want to increase the thickness, what you're usually chasing is strength and stiffness. But remember, while it does increase strength overall, you're going to have the most noticeable effects when it comes to torsion and bending forces. A great example of a part we'd bump up these thicknesses for would be something like the arm of a hand crank, because it's going to be exposed to these forces. So if this was our part, depending on what we'd be using it for, I'd probably bump it up maybe a couple of layers on the top and bottom, and maybe a layer or 2 in the vertical shell. Another practical example would be this GoPro handle mount here. On this thing I would definitely bump up the horizontal thickness to 3, maybe even 4, that might be a better idea. A quick little tip, as you can see, because we've made the shell so thick here, this top section is completely solid, and this is going to be really handy, as this is where the part is most likely going to fail. A bit more niche, but if your part is going to be exposed to abrasive forces, a thicker wall is going to help a lot. So if I was printing something like this gear here, I would definitely double the vertical walls to 4, maybe even 5. And this is going to give us a bit of breathing room in case our teeth get worn down a bit. So just for a little bit of context about how often you'd play around with this, I think about 5 to 10% of the time I've reduced the shell thickness on a part, about 25% of the time I've increased it, and for the remaining about 70% of the time, I've just left it on the default settings. And this is because it's a really great balance between having a strong part and not using too much material.